So 4C16, a ship A is traveling due east at 24 kilometers per hour. Second ship is traveling at 33 kilometers an hour. It's first sighted 20 kilometers due south of A. From a ship A, the ship B appears to be moving northeast. Find the direction which B is actually moving. Find the velocity of B relative to A, and find the shortest distance between the ships in subsequent motion, and then the last part. And I'm not even sure the problem is really with the last part. Okay, so let's set this up. We have ship A is traveling due east at 24 kilometers an hour. B is sighted first 20 kilometers south of A. So that's B, and that's A. Now we've got that drawn. We can now add in the rest. So sometimes the information you want isn't actually where you want it. It's not in sequential order. But we'll deal with what we have. We have this ship A that's going here with a velocity of 24 kilometers. And that's in the I. And we have B that's a little bit different. It's moving at a velocity, so VB is 33. What it says, though, is that ship A, from ship A, using this as our anchor, the velocity of this appears to be moving northeast. Now, you've been with me for long enough to know that northeast isn't a random direction. It's specific. It's got a 45-degree angle there. And I know last week we spoke with that. So what I know about this is, I know it's 33. So it'll be 33. Sorry, apologies, that's not 33. But V, the velocity of B relative to A, I know we'll just say it's PI plus QJ. And I know because they're both, the adjacent side and the opposite side are equal. So I can say that P is equal to Q. So the number of P is equal to Q. So VBA is equal to VB minus VA. VB is equal to 33 times, so I lost somebody. Well, where is VB going? Okay, this is where do we think it's going? Okay, I'm going to predict that it looks like it's going this direction. Is that okay? But it doesn't really matter. And I say this because I don't actually care. I'm just putting in a diagram. So make this here angle alpha. And so the 33, VB is 33 cos theta in the I, plus 33 times sine theta in the J. Minus VA, so minus 24I. Okay, I know that's equal to VBA. I said that VBA was equal to P plus Q, PI plus QJ. I said that P was equal to Q. So if I stop for a second and just go VBA, but in terms of I, well, that's equal to 33 cos theta I minus 24I. And then VBA in the J is equal to 33 sine theta, and that's in the J. Is that all right? So if you like, going back to what I said up here, we can say this is P and this is Q. And if P is equal to Q, you can say that 33 cos theta, and I don't need the I's this time, minus 24 is equal to 32 33 sine theta. Oh, can you see that? No, you can't. Can now. Is everybody happy with that? Can you show a thumbs up if you're okay? Please. Go. Great. Okay. Sorry. Okay. So we solved these before. We solved these before in chapter 0. Chapter 0, part D, I think it was. It wasn't the first section, it was the second section. And so the solution to that is to square both sides and to solve it from there. So that's the first thing we're going to do. We're going to solve it from there. So when I square both sides, I think I should take my work up here. So 33 cos theta minus 24, and that's all to be squared, is equal to 33 sine squared theta. And that is just, oh, so excuse me, sorry. 33 squared is 512. I can, yeah, just put that all to be squared. So that's equal to, oh, calculator, 1089 sine squared theta. The other side's a little more complicated, but not much. 1089 cos squared theta, and then 33 times 24 times 2 is minus 1584. The minus sign came from there. And minus 24 squared is 576, I think. Plus 24 squared. Yep, plus 576. Everybody's happy with that, I should hope. So now the next trick, the trick is in the log tables, you will see that sine squared A plus cos squared A is equal to 1. We can use this to get rid of the sine squared and to get a quadratic in only cos. Oh, excuse me. That's 1584 cos theta. So by rearranging this, I get, that leads to sine squared A, actually I'll just leave it as theta for this occasion, is equal to 1 minus cos squared A. Left it over that side for a reason. So I'm left rewriting that equation. I won't. I'll go 1089 minus 1089 cos squared alpha. That needs to be brought into this 1089 cos squared theta. That's theta. Minus 1584 cos theta plus 576. So you should work on solving this as along with me. You're obviously going to do this differently and fast, different speeds, but definitely be minus. So what we have here is a quadratic. This is our A term. This is our B term. Ooh, this is our B term, and this is our C term. You can race me on that one, folks. Do you want to try and solve that there, please? Definitely. There it is. So I cheated to find that cos theta was equal to two answers, of course, 0.97 and equal to minus 0.243. Yeah, I take it that's okay. Yeah, they're visible. Put that line in there. And then the question was, okay, yeah, so these are all valid angles. Let's have a little look at what those angles would be. So inverse of cos of that. Inverse cos of 0.97 is 14 degrees of inverse cos of minus 0.243 is equal to 104. So they're valid angles. What do they mean? One means that this angle here is 14 degrees. One angle means it's 104 degrees, so it's going that way. Now, the math says it's going that way. Sorry, the math says that it'll work both ways. It will appear that way for both directions. Okay, so fine. So we would all anticipate that it's going this direction, and so that's the one we have. So actually, and this comes back to what we saw earlier in the survey, that I want to know the actual velocity. Sorry, I want to know the direction which is moving. Well, then I can say it's simply east 14 degrees north. And you can say north 14 degrees of east if you would prefer, but you've got to write them fully out. Okay, so choice is yours. You've clearly marked your angle. It's very obvious. So I'm going to leave that page. Using this, I want to find the velocity of B relative to A. Well, I didn't have a velocity of B previously, so I shall now. It's equal to 33 cos 14 plus 33 sine 14. 32 I plus 8 J. I hope you can see the calculator there. Sorry, you can't. Yeah, there you go. So VA was simply 24 I. So VBA was equal to 32 minus 24, 8I plus 8J. And that's going in the northeast direction. Thank you. Okay, so fine. So then it says to find the shortest distance between the ships in subsequent motion. Just come back to the last diagram. I will redraw this. I'm not going to just let this one squander, but I will just continue it on. Just explain what we're doing. So this is the velocity of the ship of B to A, and so we should remember that the shortest distance is this one here, and this is at right angles. This is at right angles to the velocity of B to A. We're looking for the shortest distance, so we just find the sign that. But anyway, let's go. Redraw. We'll just put in what we need in this triangle. That's A. That's 20. And I know that the vector of the VBA, the velocity of B to A, goes in a 45-degree angle. So I'm looking for the shortest distance here. It's a right angle triangle with 45 there. So this side here, and I apologize if you've difficulty seeing this second triangle. Maybe I should draw it a bit clearer, bit of a highlighter. It's this triangle here. I know this side is hypotenuse. I'm looking for this side over here. So that is 20 times sine 45. Which is 10 root 2 or 14.14. What's the kilometers? Just check that question. Yeah, it doesn't say for meters around, so that's fine. There's another thing then says the next question says the time that elapses between their, sorry, I'll show it to you. You can read it yourself. The time that elapses after the first sighting. So after it's been sighted at 20 kilometers. So it's as if the limit of visibility at this day is 20 kilometers. The time that elapses after first sighting before the ships are seen, again, 20 kilometers. So we got to find out is, I'm looking for time. So I need to know the time it takes to get to here. So in order to do that, I need to find the distance because I have a velocity. Okay, so time is equal to distance divided by velocity. I'm going to have to double this time because this triangle is going to write itself here, and this will also be the time. So I'm looking for 2t eventually, but let's find d. Well, it's fortunate enough because this is a 45-degree triangle. A right angle with 45. So that means this side here is also 14.4. So I'm looking for t for starters, and that's equal to d over v. That's equal to 14.14. If you don't get what I'm doing, I found the cos, because it was the adjacent side, of 20 times the cos of 45. Okay? This is the same as the 20 sine 45. Okay, you figure that out. V was 8i plus 8j. So the magnitude of VBA is equal to root of 8 squared plus 8 squared, which is root of 128. Oh, calculator. So root 128. That's equal to 11.3. So the original to the single time, that's the time from the start point to the shortest distance, excuse me, is 14.14 divided by 11.3. So that took 1.25, 1 1/4 something. What was it? It was in kilometers per hour. So it's 1 1/4 hours. And therefore I didn't want t, or sorry, excuse me, I did want t, but actually really my answer was going to be 2t, the time from here to. That's also t, and that's fine. So 2t is equal to 2.5 hours, which is 2 hours and 30 minutes, if you like. Makes